the last three sessions under Unit 3, we've looked at phenanthrene and anthracene, their nomenclature, their synthesis, and synthesizing their derivatives as well. Now, in session 4 under Unit 3, this session we are going to look at reaction of anthracene and phenanthrene. So at the end of the session, you should be able to provide the product form when anthracene reacts with or is treated with chromic acid in glacial acetic anhydride. You should be able to describe the preparation of fluorinol from phenanthrene. You should be able to describe the substitution reactions in both anthracene and phenanthrene. So the first reaction we are going to look at is the oxidation reaction of anthracene and phenanthrene. So depending on the kind of oxidizing agents being used, a whole lot of different products can be produced. So you can see that here we have our phenanthrene being reacted with different oxidizing agents, producing a whole lot of different products. So if you react this with potassium dichromate, this is produced. Reducing this structure again with sodium dichromate also leads to the production of this diphenyl carboxylic acid as well. Now, treating this in warm potassium hydroxide can lead to the formation of this ring system, which can then be heated to remove carbon dioxide to produce fluorinol, which is an important agrochemical agent. Now, fluorinol can also be oxidized to fluorinon. Now, this fluorinon is an important antibiotic agent which has been used in the treatment of diseases such as Mycobacterium tuberculosis. Now, the next one we'll be looking at is the reduction of anthracene and phenanthrene. Now, both anthracene and phenanthrene can be reduced to 9,10-dihydroanthracene and 9,10-dihydrophenanthrene, respectively. So, when this is treated with sodium metal in methanol under reflux, then we can produce our 9,10-dihydroanthracene or our 9,10-dihydrophenanthrene. Okay, so apart from using the sodium metal in ethanol under reflux to produce the 9,10-dihydroanthracene and 9,10-dihydrophenanthrene, respectively, using the anthracene and phenanthrene, other catalytic hydrogenation processes can also be used in the production of these same products. So we have other catalytic reagents which can also be used to produce the same 9,10-dihydroanthracene or 9,10-dihydrophenanthrene from their parent compounds. Okay, so just like any other aromatic systems, phenanthrene and anthracene also undergo electrophilic substitution reaction. However, these reactions are of little value in their synthesis because of the formation of a wide variety of mixtures and then other polysubstituted derivatives. So, with the exception of a few, example being the bromination, which produces a product or attaches itself to the ninth carbon known as the 9-bromophenanthrene compound. Now, this 9-bromophenanthrene can be used to synthesize certain useful compounds because it serves as the intermediate in the synthesis of certain useful anthracene derivatives. So you can realize that here we have our di-substituted bromophenanthrene compound being treated with heat or being refluxed to remove one of the bromine group, leading to the production of our 9-bromophenanthrene products. Now, these are other products that are formed after the synthesis of the intermediate 9-bromophenanthrene. So the 9-bromophenanthrene intermediate is a very important intermediate in the synthesis of certain substituted phenanthrenes, because when that is produced, now the reaction of this intermediate with other reagents can lead to the formation of certain important derivatives. You can realize that even this anthracene here has now been completely transformed into phenanthrene. Sorry, this phenanthrene here, the 9-bromophenanthrene here has been treated with quite a number of products, leading to even the synthesis of anthracene, and then even the synthesis of some monosubstituted anthracene and what disubstituted anthracene. So next is to look at the nitration of anthracene and phenanthrene. Now, nitration of anthracene with aqueous nitric acid leads to the formation of an anthraquinone. So when this is treated with nitric acid, aqueous nitric acid, it leads to the formation of this anthraquinone. So please take note of this. Now, however, in acetic anhydride at 15 to 20 degrees Celsius, two products are formed. So when you do your nitration with your aqueous nitric acid in the presence of acetic anhydride at 15 to 20 degrees Celsius, then you form two different products. So you have the product A and the product B. So please, let's take note of these two products that are produced in the nitration of anthracene. Okay, so next is to briefly look at sulfonation reactions of anthracene and phenanthrene. Now, to take anthracene, anthracene is readily sulfonated at room temperatures to give a mixture of 1 and 2 sulfonic acids, right? So the product is formed, and this product is a mixture of 1 and 2 sulfonic acid. Yeah, so 1 and 2 sulfonic acid. However, at high temperatures, the sulfonic acid derivative at carbon number 2 on anthracene is produced. So mostly when we are more interested in producing our derivative with the sulfonic acid attached to the carbon number 2 on anthracene, then high temperatures is preferred. Now, in nitration, phenanthrene gives a mixture of 3 mono-nitro derivatives. We have one at carbon number 1, carbon number 2, and carbon number 3. However, the isomer with the nitro group at carbon number 3 is the main product. So please, let's take note of that. So in nitration, we have carbon number 3 derivative with the nitro group attached to the phenanthrene ring being the main product. So in sulfonation of anthracene and phenanthrene in glacial acetic acid, for phenanthrene, phenanthrene gives a mixture of 1, 2, 3, and 9 anthracene sulfonic acid. However, anthracene produces equal amounts of 1 sulfonic acid anthracene and 2 sulfonic acid anthracene. So equal amounts of each substituted derivative is produced. So the 1 substituted sulfonic acid anthracene is produced, the 2 substituted sulfonic acid anthracene is produced, and they are in equal amounts in the mixture.